Hi class. As you can see, this guy has quite the expressions up above, making quite the different faces. A few quite interesting. I don't know about you guys, but yeah, again, these are not the expressions. No, 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 no. These are not the expressions we are talking about. This is math class. We don't have things like faces. We have things like numbers and variables. So, moving on. First thing, we have like terms. Today we are going to simplify algebraic expressions. Like terms are two terms, and yesterday, or your last video that you were watching, we defined two terms as something being multiplied or divided together that contained a variable, or it could have just been a constant like a number. So we could have terms such as x over 7, 5x, we could even have 2. 2 is a term by itself. So if we want to have like terms, we need to have terms that are the same. So like terms are two different terms that we have. They need to have the same variable and the same exponent to those same variables. So if we would say like terms, if we would have a 3x to the 7th and then a 5 or a negative 5, x to the 4th, they are not like terms because one has a 4, one has a 7 as the exponent. The x's are the same, but the exponents are not the same. So if we would say xy to the 4th and then 7xy to the 4th, those are like terms. So we'd say ding, 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 we have a winner. Both of them have an x and a y, and the y's on each one both have a 4 as an exponent. So they are like terms, which means we can combine them together. So if we look at some examples here, if we look at number 1, first thing is both of these terms, again terms and algebraic expression, are connected between an addition or subtraction sign. So two terms, they both have just a z. The exponent, there's nothing written up there. So we can combine these like terms. Our variable will stay the same, and we just use the sign in the middle to determine what we will do with our two coefficients, the numbers in front. So 4 plus 6 is 10. So we would have 10z. Moving on to number 2. Again, we see x squared. X squared. They are like terms. We can combine them together. So in our answer, we will have an x squared. Here it says we are subtracting this time. So 6 minus 14 would be a negative 8. So a negative 8. Yes, we can have many negative numbers. They will not always be quite as pretty as maybe what you were used to. So we look on to number 3. We have an x squared and an x. There is no variable up there. It is not a 2. So guess what? Right here, and I can undo that right now, that is our answer. They are not like terms. An x squared and an x. The variables are the same, but the exponents are not. So we cannot simplify that any further. So that is 7x squared plus 9x. Okay, so those were a little bit easier ones. They each had two terms. We're moving on to number 4. Again, reminder, you can always pause the video if you need to go back and look at something where I am talking too fast. So number 4, we have an x squared term and an x squared term. We also have a number without an x and a number without an x. So the underlined ones, both are x squared, so those are like terms, so we can combine them together. So let's go ahead and do that first. So we have a 3. On this one there is no number or coefficient in front, but we do have this minus sign that is going to become that we need to use because it's in front here. We don't care about this addition sign over there. No, no, no. Only the one in front of our like terms do we care about. So it's a positive 3 minus, we always have an invisible 1 in front of our variable, so 3 minus 1 is 2. So that would be 2x squared. And then we move on to our other ones. Now our circles. 7. It's a positive 7. Plus 2 is a positive 9. So we write plus 9 because it is a positive 9. So now we have an x squared term and we have a 9 without an x squared term. Cannot combine those together anymore, so that is our simplified expression. Now we're getting more complicated. It's starting to get a little bit more exciting. We have to reach back into our tool pocket in our math kit, and we need to remember the distributive property. A number in front of parentheses, a number smushed up against something else means multiply. So 3 times x is 3x, and 3 times 7 is 21. So we must distribute first. Okay, so distribute first, then bring down the plus 5x. Now let's see, can we simplify or combine like terms? Well, x, so 3, positive 5, so 3 plus 5 is an 8. We'll write our answer over here, 8x. And then our leftover term, that one does not have an x, so we just kind of put it on behind. It is a little bit of a lonely number there, but it does give us our simplified answer. Now, example number 6, we're getting even more complicated. More numbers are being thrown in there. Again, we have this 5 in front of a parenthesis. It's a positive 5. We need to distribute first before we can do anything else. Otherwise, we can't do anything else until we do that. So, bring down the 3x. Then let's distribute our positive 5. So 5 times x is a positive 5x. So we write plus 5x. 5 times a negative 2. So 5 times a negative 2 is a negative 10. So we write down minus 10 because it was a negative 10. Next, we bring down our positive 2 at the end. Now, after we are done distributing, we look back. Now we have like terms we can combine. So if we look, we have our first two terms both have an x. So 3 plus 5 is 8x. Our last two terms, both just numbers. So of course we can add and subtract that. We have a negative. Don't forget the negative here. Negative 10 plus 2 is a negative 8. So we ended up with 8x minus 8. Number 7, this is our last example. It is a little bit more tricky. I want to bring everyone's attention to this negative sign in front of the 2. Do not forget, when you distribute, we're multiplying when we distribute, you need to multiply by a negative 2. Okay, so I'm going to bring down the 9. Multiply both things by negative 2. So negative 2 times positive 2 is a negative 4x. Then negative 2 times negative 5 becomes a positive 10. Go ahead and simplify all of that. And I messed up there. Go ahead and simplify. Oops, didn't get the eraser. Simplify when negative times a negative, just make it a positive and write a plus there. Okay, fixed it. Now let's go back. We want to find all of our like terms. So we have a 10 and a 9 and a 10. So 9, it's a positive 9. There's nothing in front. 9 plus 10 is 19. We'll write that one second. Always put our variables first. Then we have a negative 4x. Make sure you keep that negative there. Minus this 11 over here. So negative 4 minus 11 is negative 15x. That was a positive 19. We didn't write anything in front, so that's going to become a plus. So negative 15x plus 19 is our simplified form of this expression. All right, go ahead and head on to your IXL.